17th lecture. We will continue studying Markov processes, and in this lecture we will study classification of states. There is a small recap before we study today's topic. Long-term frequency of visiting states. We represented the scenario for which if we have at state I at time t is equal to 0, the probability that we will be at state j at time n, and there are multiple time intervals in between, is represented with small r sub ij of n, where I is the initial state at time t is equal to 0, j is the state at time n, and of n means after how many states. N can be any integer, 1, 2, 3, 4, for example, all these integer numbers. Right. In today's lecture, we'll study about accessible states and recurrent states. Right. We first study accessible states. Accessible states. We want to see whether this state j is accessible from I after time n or not. Right. This is the question, whether this state j that can be the same as I or can be a different state is accessible if we start moving from I. If we start moving from I, if this state j is accessible at time n or it is not accessible. Right. So to answer this question, the process at time n is in state j, given it was in state I initially, it should be this Rij of n should strictly be greater than 0. If it is greater than 0, this means this state j is accessible from state I after n time units. This we call as accessibility. So the states are accessible or they are not. So if Rij of n is greater than 0, this means after time n time steps, this state j will be accessible from state I. The formula to compute Rij of n was studied. Rij of n. We studied this formula in last lecture. This is the formula, is that we are given one previous state. From we assume that we are in state k at time n is equal to at time n minus 1. At one previous time we are in state k, and this k can take on any value from the given state space containing all the states. If there are m states in our state space, so given, we'll try all values for k from 1 to the last value of the state that is given our state space. For pkj is the probability that at time n minus 1 the state is k, and at time n it is j, where Rik is the same formula we applied at n minus 1. So it's a recursive formula. We will repeat it again and again unless we reach to the first state. Right. So if this Rij of n is greater than 0, this means state j is accessible from state I after n time steps. Right. The second thing that we will study today is the recurrent state. In a given state space, a state I is called recurrent if we'll define a set A of I for a state I, where set A of I contains all the states that are accessible from I. If A of I is the set containing all states that are accessible from state I, then state I is recurrent if the state I is in the set of accessible states of J. Then what is J? J is in the set AI. It's something isn't very easy to understand. We will try to understand this single expression with the help of an example. A of J, A of I and J. There are four terms which we have to understand. That we have to understand. I is the state for which we are going to make a decision whether it's a recurrent state or not, where J is a member of the set of all possible states that are accessible from I, where A of J is the set of all the states that are accessible from J, where J is a member in A of I. Oh, it's really complex to listen. It's really very complex. Let's solve it with the help of an example. We are given this change. Let's try to understand this expression with the help of an example. Right, we are given this chain and we want to find out whether this 2 is a recurrent state or not. We'll call it I. We should call it I. So what is A of I? Since I is 2, A of 2. The states that are accessible from 2 are 1 and 3. 1 and 3. Now we will see what are A of these 1 and 3, the states that are accessible from the state we are going to make a decision. So A of 1. What is A of 1? The states that are accessible from 1 and 2. So A of 1 is 1 and 2. 1 and 2 states 1 and 2 are accessible. States 1 and 2 are accessible from 1. So A of 1 contains 1, 2. Whereas for state 3, we have 2, 3, and 4. So states 2, 3, and 4 are accessible from 3. So let's see whether, since this 2, we have to check this 2, I, whether it is in this set and in this set. If this 2 is in both these sets, then 2 is a recurrent state. So we find 2 here and we find 2 here. Right, this means 2 is a recurrent state because it is present in A's of those states that are found in A of 2. Right, but now we will be doing an example for which 2 is not recurrent. Right, in this example, A of 2 is 1 and 3. This means state 1 and state 3 are accessible from 2. So now we'll see what is A of 1 and A of 3. A of 1 contains 2 and 4. So 2 is here. This means half of the condition is fulfilled. But in A of 3, 3 doesn't go anywhere. So this means the states that are accessible from 3 is 3 itself. So 2 isn't there. This means the condition isn't fulfilled. Since 2 is not in A of 3, this means state 2 is not recurrent. Right. We will, in our next lectures, we will continue studying more about classification of states. Thank you.